Hi everyone! Today we want to talk about function generators and driving a simple inverter circuit. The goal of this video is to show how changing the voltage and waveforms can turn a MOSFET on and off and see the effect on the load. In this test, I am using the PICTEC 1404 oscilloscope and the PICTEC 4121 function generator. I am using an LED, an ATX power supply transformer, and a MOSFET. The function generator current is limited. High voltage or current can damage the device, so always work with caution. Note that the function generator ground is connected to the earth. A wrong connection to power circuits can cause a dangerous short circuit. Always check your connection points before attaching probes to avoid contact with the earth. Here we use an N-channel MOSFET, model IRF3205. This MOSFET has 3 pins: gate, drain, and source. The gate pin is the controller. It acts like a large capacitor. Imagine the gate is like a water glass. It must be filled to turn the MOSFET on. It needs about 10 volts to turn the gate on fully. The drain connects to the load, and the source connects to the ground. The MOSFET can switch the load on and off at high speed. It is used in inverters and power switching circuits. I used a 120 ohm series resistor for the gate. This limits the pulse current and protects the function generator. Also, I put a 10 kilo ohm pull-down resistor between gate and source. This empties the gate charge when there is no signal. Without this resistor, the MOSFET might turn on randomly. These two resistors together make the MOSFET work correctly and keep the switching stable. I am using the PICTEC 4121 function generator. It has a single output and can produce standard and custom waveform. It gives 25 volts peak-to-peak in sine wave, which is a great feature. Now let's learn how to use it. The body is metal and it weighs about 3 kilograms. It has one main signal output and one sink output. The sink output is an extra output. It sends a reference signal to the oscilloscope for synchronization. But in the 4121A model, there is an internal amplifier that provides up to 10 watts of power. The function generator can produce different waves, like a square, sine, or ramp. We can also change the peak-to-peak voltage. This shows how the waveform and amplitude affect the MOSFET. Function generators usually have a 50 ohm internal resistance for impedance matching. When connected to a high Z load like a MOSFET gate, the voltage is almost the same as the device setting. If you connect it to a 50 ohm load, the voltage will drop by half. VPP or peak-to-peak is the distance between the highest and lowest points of the wave. The output current is limited. At high frequencies, it may not charge the gate fast enough. This makes the MOSFET get hot. This is an arbitrary generator. We can create custom waves or use the built-in ones. I connected the power supply to the first pin of the transformer and the 5 pin to the MOSFET drain. The MOSFET source is connected to the power supply ground. I have a 100 ohm resistor on the gate and a 10 kilo ohm pull-down resistor between gate and source. There is an LED at the transformer output. When the function generator sends a signal, the MOSFET switches and the load turns on. Now back to the function generator. Let's turn it on. Use these buttons to change the waveform. To change values, select the option button. Then use this knob to change the value. For example, to change the frequency, I press F1. The number flashes, and I turn the knob. For exact values, use the keypad. Enter the number and select Hertz or Kilohertz. First, I choose a square wave. I set the voltage to 5 volts peak to peak and the frequency to 30 kHz. The power supply is set to 12 volts and 1 amp. When I enable the output, the MOSFET receives the signal, turns on, and the light glows. If I increase the voltage, the gate charges faster. The MOSFET turns on better, and the light gets brighter. If I decrease the voltage, the gate charges slowly. The MOSFET doesn't open fully, and the light gets dim. This is because the MOSFET gate is like a capacitor. Without enough voltage, it doesn't charge fully. I increase the voltage. Frequency is also important. At 70 kHz, the light is still bright and stable. I set the peak-to-peak voltage to 4. But below 20 kHz, the light becomes unstable because the load cannot react well at low frequencies. I'll set the frequency to 50 kHz again. I'll also increase the voltage. Now I change the waves: sine, ramp, and noise. The reason it works is simple. The MOSFET is a voltage-controlled switch. If the gate gets enough voltage, it turns on. In a ramp wave, the voltage rises slowly. Here, the MOSFET acts like a half-open water tap, which creates heat. In general, the waveform affects the switching speed and the heat of the MOSFET. Now, press the arbitrary button to see the menu, then press F4. I choose the Blackman wave and press Select. The circuit is now active. If I choose a triangle wave, the light stays off because the effective voltage is too low to charge the gate. So guys, in this video, we saw how to easily control a MOSFET with a function generator. We learned that changing the voltage and frequency affects the switching speed and the light. Don't forget that gate and pull-down resistors are very important for safety and performance. This method is only for a small test. For real power projects, always use a gate driver. I would like to express my gratitude to Patrick for sending these devices to me. Thank you very much, Patrick. I put the link to the PicTech website in the description box. Thanks for watching. I hope this video was helpful for you.